Welcome to ChemDoctor, and this is the second presentation on the basics of electron configuration. And what I want to do in this video is literally practice with you how to do electron configurations for the first three period elements. So period 1, period 2, and period 3. And literally what we're going to do here is motor through the configurations for each one of these elements so you get the feel for how it's done. All right, so in period 1, the first element we have to deal with is hydrogen. All right, and its atomic number is 1. So I think it might be helpful if I put the standard configuration up here at the top of the presentation. And keep in mind that what we're working with here are only the first 3 periods. So we're only going to be dealing with elements from hydrogen to argon, where argon has got a total of 18 electrons and hydrogen has 1. So, and additionally, the major principle that we're using to generate the configuration is called the Aufbau principle, where the idea here is that we start at the lowest energy level and we move upwards as we fill each subsequent level. Remember that s orbitals hold a maximum of 2 electrons and the p orbitals hold a maximum of 6 electrons. All right, so let's see how this works. So for hydrogen, which has an atomic number of 1, its electron configuration is going to be 1s1. All right, now in the first video on electron configuration, I talked about valence. And for hydrogen, its valence is equal to its electron configuration in total because it only has 1 electron. So that's how come we find hydrogen, for example, in group 1A if you're looking at a periodic table. All right, now the next element moving across period 1 is helium, which has 2 electrons. Its configuration is going to be 1s. Remember, the s orbitals hold a maximum of 2 electrons, so its configuration is 1s2. And again, using the same rationale as hydrogen, this configuration also represents its valence. So in the case of hydrogen, this electron is the surface electron. In the case of helium, these 2 electrons are the surface electrons. The surface electrons and the core electrons for hydrogen and helium are the same. All right, now let's go ahead and move on to lithium. So we've just stepped down to period 2 and we move to the far left side of the periodic table. So lithium has an atomic number of 3. Its configuration will be 1s2. This is completely full now, and then 2s1. Now, when we hit lithium, we have to start differentiating the electrons. The 1s2 electrons here are the core, and they are not involved in chemical reactions. This single electron, which we find out here in the 2s shell, is the valence. All right, or the surface electron. Surface electron. So this is going to be the electron that is going to be involved in any kind of chemical reaction that lithium might undergo. All right, the next element to the right is going to be beryllium. 4. So its configuration is going to be 1s2, 2s2. I'm going to underline the valence in red. Here's my valence. All right, here's my core. All right, next element to the right is going to be boron. Total of 5 electrons. So it's going to be 1s2, 2s2, 2p1. All right, again, I'm going to underline my valence in red, this whole thing. Note that boron is in group 3A. So if you count the electrons, there's 1 and then 2 more here for a total of 3. The core electron is here. All right, next element to the right is carbon. We've got 1s2, 2s2, 2p2. I'm going to underline my valence in red. Here we go. 4a. Group 4a. All right, here's my core. I'll circle it. Next element to the right, nitrogen, 7. All right, 1s2, 2s2, 2p3. 3 and 2 is 5. So if you look at the group number for nitrogen, it's in group 5a. Here's the valence. These are the surface electrons that are involved in the chemical reactions. Here's my core. All right, next element to the right is oxygen. Atomic number 8. 1s2, 2s2, 2p4. 4 and 2 is 6. Oxygen is in group 6a. So here's my valence. Underlined again. All right, and the 1s2 electrons are the core. So here's my valence. Next element to the right, fluorine. Atomic number 9. 1s2, 2s2, 2p5. 5 and 2 is 7. Okay, here's my outer valence underlined. Here's my core. Next element to the right, neon. 10 electrons. 1s2, 2s2, 2p6. Here's my valence. Note this shell is totally filled and it gives us our magic number of 8. Okay, noble gases have 8 electrons in their outer valence, except for helium, because it only has 2 electrons, has a smaller number, but its outer shell is totally full. All right, now from neon we move to sodium. We're now in period 3, moving towards argon. And what we're going to have here will be 1s2, 2s2, 2p6, 3s1. Okay, here's my outer valence. Okay, here's my core. All right, next element to the right, magnesium, 12. 1s2, 2s2, 2p6, 3s2. Okay, here's my outer valence. Here's my core. All right, next element to the right, aluminum, 13. 1s2, 2s2, 2p6, 3s2, 3p1. Here's my outer valence. All right, here's my core. Okay, next element to the right, silicon. Atomic number 14. Right, this guy is right underneath carbon. Okay, configuration 1s2, 2s2, 2p6, 3s2, 3p2. All right, valence. Core. The core is not involved in chemical reactions, only the valence. All right, let's see. Next element to the right. Phosphorus. 15 is the atomic number. So 1s2, 2s2, 2p6, 3s2, 3p3. Here's my valence. Here's my core. Notice there's 10 electrons in the core. And the valence, if we add the 3 and the 2, we get 5. So it should be no surprise that phosphorus is found in group 5a. All right, next element to the right, sulfur. 16 is the atomic number. This guy right underneath oxygen. Group 6a, that means this should have 6 valence. So let's see what happens. 1s2, 2s2, 2p6, 3s2, 3p4. Outer valence. Okay, and you can see 4 and 2 is 6. Here's my core. All right, next element to the right, chlorine. Atomic number 17. 1s2, 2s2, 2p6, 3s2. Whoops, let me fix that up better. Okay, 3s2 and then 3p5. Okay, let's underline the valence. 3s2, 3p5. 5 and 2 is 7. So chlorine is found in group 7a. Here's my core. All right, finally we got argon. 18 electrons. 1s2, 2s2, 2p6, 3s2, 3p6. All right, let's underline the valence. Notice that there's 6 and 2 is 8. Here's our magic number again. This is found in group 8A. All right, and here's my core. All right, and with that, I'm going to go ahead and close the video. Remember that only the valence electrons, only the surface electrons are involved in chemical reactions, the formation of ions due to the exchange of electrons, or the formation of covalent compounds by a reaction.